All right, so today we're going to be doing the 2.2 notes day 3. So make sure you're, say, lesson 2, day 3 up here. Our goal today is we are going to write an equation of a line, which is what we've been doing. But today we're going to focus on lines that are parallel and or perpendicular. So our goal today is to write an equation of a line parallel or perpendicular to a line through a given point. So I'm going to give you an equation and a point. I'm going to tell you to write an equation for a line that would be parallel to that given line. So if you can picture that, here's a line. I'm going to give you another point, and I'm going to say write an equation of a line that would be parallel to this line. Can you picture parallel? Yeah. Okay, parallel to that line going through that specific point. If it was perpendicular through a point, you'd have a point, and you'd have to imagine it going perpendicular. Show me with your arms, what does it mean to be parallel? What does parallel look like? Okay, good. So they're running like alongside each other. So for our online students, they kind of look like this. Okay. What about perpendicular? Show me with your arms, what does it mean to be perpendicular? They are going to cross. Yep, they intersect. But there's something more specific. Ties looks good. What is the more specific? How do they cross? Because not only do they cross, this would not be considered perpendicular, but something like this would be. What kind of an angle? There's a specific angle. A right angle. So two lines that cross to form a right angle. So the parallel, if I was to write an abbreviation, sometimes I write it like that. They look like slanted L's. And then perpendicular looks like an upside down T because that forms a right angle. So that would be shorthand for parallel or perpendicular. We often use those in geometry. Did you use those in geometry last year? Not those symbols? But you learned about parallel and perpendicular last year, right? Okay. So characteristics of parallel lines. If you have two lines that are parallel, they look like they're running in the same direction, they are going to have the same slope. Okay, so I'm going to give you two equations here of lines that might be parallel, or that are parallel. Y equals 7x minus 4. That's your first equation. What is the slope of that equation? 7 over 1, or just 7, right? So if our slope there is 7, our second line that is parallel to that also has to have a slope of 7. Okay? It doesn't matter what the y-intercepts are. You want them to be different. Maybe that one's plus 5. Okay, your y-intercepts are going to be different, but the slopes are going to be the same. Why can your y-intercepts not be the same? It would be one line. If they were the exact same, if your y-intercepts were also the same, then they would just be one line. Okay? If a line is over top of another line, if it's the same line, are those two lines parallel? No, because what's the definition of parallel? But does anyone remember? They never cross. They never intersect. Yep. And if they were right on top of each other, they would always be intersecting. Okay? So they never can intersect. To be perpendicular, these slopes have to be opposite. Okay? That's why we practice that so much in Unit 1. What does it mean for something to be opposite? And they have to be reciprocals, which is why we practice that so much in Unit 1. They have to be opposite and reciprocal slopes. Okay, so if I write my first equation, what is the slope of this first equation? 3 over 1. So I'm going to write that right here. M equals 3 over 1. So if I need this slope to be opposite and a reciprocal, what is that one going to be? This was positive, so this one has to be negative. This was 3 over 1, so what's this one going to be? 1 over 3. So this one, an example might be something like y equals negative 1/3 x plus 7. Okay. Again, we don't really care what the y-intercepts are. They could be the same, though, for this one, because these two lines, they look like this, right? So eventually they will cross. They could cross at the y-intercept, so we don't care if the y-intercepts are the same or different here. All right, we're going to practice a couple of these. Graph and write an equation of a line in slope-intercept form that goes through 4, -1. What does slope-intercept form look like? Let's write that down. And if you're not sure, look back at lesson 2, day 2 notes, and we have that little chart of what the 3 different types are and what they look like. So what does slope-intercept form look like? Y = mx plus b. So that's what we want our equation to look like. And it's always good if when you see what it's supposed to be, go back and write it in. What should my answer look like? So that we know that our answer is on the right track. Okay, that it's in the right form. So let's start with graphing this line. Because we want to have a line that's parallel to that, going through a given point. Okay, how would I graph this equation, y = -3/4 x minus 4? What's the first thing I'm going to do there? I'm going to mark the y-intercept. Where's the y-intercept? What? 0, -4, right? We always say at this point. So here's my y-axis. 0, -4 is right here. And then how does my graph move? How does that line move after I plotted that first point? What's my slope say it is here? So how does the slope -3/4 move? Down 3, right 4. And it looks like my scales are just 1, so I can count down 3, right 4. I'm going to go in the opposite direction, up 3, left 4, and I'm going to keep going, up 3. That one's off the graph. And then I'm going to use a straight edge. To connect all those points. So that is this line here. All right, next, I am going to try to write an equation. So my answer is going to be an equation. It has to go through 4, -1. So right 4, down 1. It's got to go through this point. And what does the slope have to be? Well, we're trying to write a line that's parallel. So what do we know about parallel slopes? They have to be the same slope. So my new line goes through the point 4, -1, so that's a point. And what is the slope of my new line if my original slope was -3/4? It also has to be -3/4 because the slopes are going to be the same. Okay? Now, if you did your lesson 2, day 2 assignment, what is the easiest form to write if we're given point and a slope? What's the easiest form to write it in if we're given a point and a slope? What is it? Not standard. Standard's very tricky to write it in. You can change things to standard form, but it's very hard to write in standard form initially. What is it? Slope-intercept would be tricky here because we don't have a y-intercept. The only one we have left is what? Point slope form. Wait, what do we have? A point and a slope. Wouldn't it make sense that point slope form should be pretty easy to write if we're given point and a slope? Okay, so remember the point slope form looks like this. Y minus y1 equals m times x minus x1. And then you fill in your slope is in m. Remember, you have to have your y, you have to have your x. What is this part here going to be? What is your y1 of your point? So what is y minus -1 then? What's that going to turn into? Y plus 1, yeah, because when you subtract a negative, it changes to adding. All right, how about the x1? X minus x1 turns into what? X minus 4. Okay. Now, is that how they wanted my answer, was in point slope form? No, how did they want my answer? Slope intercept form, y equals mx plus b. So we got to get that y by itself, which is why we practiced this on our day 2 stuff. So we're going to have to distribute that -3/4. That's going to be -3/4 x. -3 times -4 is a positive 12 over 4. But wait a minute, 12 over 4, that's just 3. -3 times -4 divided by 4, it's just going to be a positive 3. Negative times a negative is a positive. When you multiply by 4 and divide by 4, it turns into just 3. Okay, I almost have y by itself, but I have one more thing to do. Subtract 1 on both sides. And when I do that, I get y equals -3/4 x plus 2. Now that should be the answer. But let's graph it and make sure that it goes through that point that we talked about. Okay? And it has the right slope and it has the right y-intercept, which makes sure all this stuff matches up. Okay? So 0, 2. My slope says to go down 3, right 4. Oh, there I go. I hit that point. And when you connect it, I always want to double check. Did I go through the point 4, -1 like I was supposed to? Yes? Do those appear to be parallel? Yes. And if you want to get real fancy, if you remember this from geometry, you can mark them parallel by drawing the same arrow on both of the ends. If you want to mark them parallel, you could do that. You don't have to, but you can. So that one's done. We wrote the equation for the line that was parallel to the given line and going through a given point. And we graphed both of them and made sure they appeared parallel and that it went through the right point. Okay. All right. The next one says it has to be perpendicular. And remember, it also has to go through that same point. So the first thing I'm going to do is I'm going to graph the line that they gave to me. So 0, -4. This is the exact same blue line as I originally had up there. So 0, -4 is my y-intercept. And I'm going down 3, right 4, up 3, left 4, and connect it with my straight edge. So there's the original line. And then my new line has to go through the point 4, -1. And what is the slope of my new line going to be? Now remember, this slope didn't change from before, so this slope was -3/4, just like in the last one. But what's my slope of my new line going to be if I want it to be perpendicular? What's my rule for lines that are perpendicular? Has to be opposite and reciprocal. So what would be the opposite and reciprocal of -3/4? it would be positive. This was negative, so this would be positive. 3 over 4 changes to 4 over 3. Okay, so now that we have our key information, we have a point, we have a slope. Okay, what would be the best form to write this in? Now, eventually, I know that my equation that I need to get has to be in the form of y equals mx plus b down here. Okay, but I can't go directly there. So instead, when I'm given point and a slope, what do I go to? What form? Point-slope form. I'm given a point and a slope. I'm going to go to point-slope form. So I have y minus y1 equals x times the quantity of x minus x1. Here's my x1. Here's my y1. And I already labeled my m. Go ahead and write this in point-slope form. Did we get it? Y plus 1 equals 4/3 times x minus 4. How'd we do? Is it good so far? Okay. So then what we're going to have to do is we have to get y alone. First, we're going to have to get rid of the parentheses, and then we're going to have to move that 1 over. So I'm going to have to take this 4/3, and I'm going to have to distribute. Four times 4 is 16 over 3 still. Okay. When you have a fraction here, we're going to have to subtract 1 on both sides, but here you can't necessarily subtract 1 from 16/3, so I'm going to write it as 3 over 3. 3 over 3 is the exact same thing as 1, correct? Okay, but I came up with my common denominator for that one. So I'll have y alone on the left equals 4/3 times x minus negative 16 minus 3 is going to be negative 19/3. Okay, now that's going to be pretty tricky to graph because 0, negative 19/3 is going to be a tricky one to graph. However, what point does this line have to go through? What point did they give you? So if you plot 4, negative 1, what you can do from there is use that as your starting point. And what was the slope? How does the slope tell you to move? Now, what's the slope tell you? Up 4, right 3. Down 4, left 3. And then connect it with your straight edge. And we'll check and see if that y-intercept makes sense. We can see that it crosses just below 6. And if you put in your calculator, what is the decimal version of negative 19/3? So negative 19/3 is approximately negative 6.3 repeating. And that's not necessarily how we're going to write the equation because we don't use decimals in our equation. But you can see if negative 19/3 is negative 6.3 repeating, that is approximately where you're hitting on that y, for that y-intercept. So it looks correct, but that would have been really hard to try and graph that. So since we had an exact point, that one was easier to start with. Okay. Another reason why I wanted to show you that is because some people actually start with the point that they were given and their slope that they know that they have to have, and then they look at this pink line and they say, okay, I can write an equation for that pink line. I know my y-intercept is at 2, so I'm going to have a plus 2, and my slope had to be the same as the original, so my slope had to be negative 3/4. So some people find it easier to graph the original find the new point, graph the new line, and then write the equation from that. And you can do that sometimes. However, on one like this, you wouldn't necessarily be able to do it because it doesn't hit at exactly -6 or exactly -7. It's somewhere in between, and you have to figure out where, so you'd have to do it algebraically. Does that make sense? And you can even use, if you wanted to, a calculator, -16/3 minus 1. We subtracted 1. And it has to be given to me, though, in a fraction form. So now that you know this, now that you can see it, there we go. If you hit math and then fraction, it tells you that's -19/3, and we know it's -19/3. So your calculator will change it to a fraction if you do it in your calculator. Okay, so if you're struggling with the fractions part, just have your calculator do it for you. That's fine too. All right, let's flip this over. And we have something to talk about with horizontal and vertical lines. Now, we have briefly discussed this. This actually showed up on your quiz. I'm going to show you what the graph looks like first. If it is a horizontal line, it looks like this. What did we say was the slope of a horizontal line? How much fun is your ski trip? Not very fun. So what's your slope? M equals what? What number is not very much? 0. Okay. Now for the vertical line, how's your ski trip if you ski down a slope like that? What was your slope? Undefined, yep. You're not going to remember how to describe your ski trip because you probably got a really bad concussion and don't even remember your ski trip if you survived. So your ski trip's undefined on something like that. No one knows what happened. You don't even remember your ski trip. You probably don't even remember going down that hill. Okay, so that's undefined. Now, we're going to learn today, the new part is how to write the equation for this line. Okay, so what axis does this go through? The horizontal line. What axis does it go through? The X or the Y? The Y. So you look to see where does it go through. It goes through Y at what number? And it's going to be Y equals a number. There will be no X in your equation. It's going to be something like Y is 7 or Y is 4 or Y equals -3. This one's a positive number, so maybe this one was Y equals 4. Okay, that would be an example. It goes through the y-axis. That would be at 4. Y equals 4. It's a horizontal line through the y-axis at x, or through the y-axis at 4. Okay. So this one, what's your equation for the vertical line then going to look like? X equals a number. And since this one's a negative number, we'll say this is at x equals -3. So that would be how you would write an equation of a line that would be vertical or horizontal. All right, so if I give you a specific point, -5, 1/2, and the line must be horizontal, what is your equation? What axis does it go through if it's going a horizontal line? It goes through the y. So y has to equal a number. What number does y have to be if this is your point? What is the y value? 1/2. So y equals 1/2 would be your equation. Okay, so a lot of people make these harder than what it needs to be. There's no work to really show on these. We're going to plot the point -5, so left 5, up 1/2, which is right here, And then what we're going to do is we're going to draw a horizontal line through that. There's my horizontal line. It goes through the y-axis at 1/2. So y equals 1/2. We're going to try it again, but this one's going to be vertical. It's going through that same point, so -5, 1/2. But this one's going to be a vertical line. So what axis does this one go through? The x-axis. So it has to be x equals, and what number does it hit the x-axis at? Or, looking at the point, what does the x value have to be? -5. All right. So, steps for writing equations of lines given a graph. Okay? So we have to write an equation in slope-intercept form for a line that's given to us on a graph. All right. So, step 1 is to, now in slope-intercept form, that looks like y equals mx plus b. So we're going to have to identify the y-intercept. Which is going to be your b value. Then you're going to have to identify the slope. Which is your m value. And once you have that, then you just fill in the m and the b in y equals mx plus b. So you fill in the m, you fill in the b, and you have your equation. So, in example A down here, I can see my y-intercept is at what point? 2. It's at 0, 2, so the b value has to be 2. Then we have to identify what the slope is. So what would the slope of this graph be? So you want to find another good point. Maybe it's right there. And up 1/2. Oh, I guess you could have done that one there too. If you did this one, it'd go up to right 4, 2/4, but that also reduces to 1/2. So it doesn't matter which 2 points you choose because you have to reduce it anyways. So now we just fill it in. Y equals our m value was 1/2 x, plus our b value was 2. If it's a negative b value, then you're going to do subtraction. Try B and C on your own. See if you can write what the m value is. See if you can write what the b value is. You don't have to move on to writing the equation yet, but just try to get the m and the b value for both B and C. So for B, I found that the B value was 0 because the y-intercept is at 0, 0. And I found my slope to be -5/3. Give me a 1 through 5, I got those. Okay. The ends were actually right on the points. If you look, this was not quite at -2. This was not quite at 2 for the x. So we had to come all the way down here to 3, -5 for good points, and -3, +5 for a good point. For part C, I found that my slope was 5/3, +5/3, and my B value was going to be 3 because the y-intercept's at 0, 3. Give me a 1 through 5. I did that one okay. Down to a 1. I have no idea what M and B are. I already learned my alphabet in kindergarten. M's like M for monkey. B is for bee, banana. They go together great. But why are we discussing this? Right? Okay, so now that we have those two things, that's the hard part. That's the identifying. But once you have those, the rest of it should be easy. Your M goes here, -5/3 x plus 0. Do you have to write plus 0? No, you don't have to. So you can just leave it as -5/3 x. Okay. Then for this one, y equals mx, so y equals 5/3 x, plus our b value is 3. So y equals 5/3 x plus 3. So once we have the m and once we have the b, the last part is easy because it's just the filling it in. Okay. Those are all of our notes today.